Welcome back to the Lee channel. Today we're going to look at how to subtract vectors. That's essentially taking two vectors, subtracting one from the other one, which is an extension of vector addition from the last episode. Going into vector subtraction, we want to just kind of warm ourselves up to the idea a little bit. So let's take an analogy. Let's imagine you take the number 3 and then you subtract 4. You already know what this is. Of course, it's -1. But we can also write this as 3 plus -4. So essentially what that was is I took this negative sign and I attached it to the 4 and I added the opposite sign of 4, which also gives me -1. The idea of vector subtraction is very similar. It's playing with the thing that you're subtracting, flipping it around, and then adding it instead of subtracting it directly. So, for vectors, what does it mean? The same idea can be applied to vectors. All you need to do is to flip your subtracted vector in the opposite direction. Then you can add the vectors normally. So what does that look like? Let me give you an example. Let me say that going east is positive, going north is positive in this fashion. So let's say if I want to subtract this vector minus this vector. Okay, let's say that's what I want to do. So how do I flip these vectors around? Well, what this look like is I'm going to play around with my second vector over here. What does that mean? It means that instead of subtracting this guy, I am going to add, so I take this original one, I'm going to add instead this vector, but in the opposite direction. So that means if it's originally pointing towards the south, which is negative, I am going to flip it around and make it up a vector in the opposite direction. So if I had to write this out, this would kind of look like this, which is saying the first vector plus the second vector, but flipped in the opposite direction, which then would give me one vector east and the one vector going north, very much like vector addition. Adding vectors tip to tail, which means my resultant vector is from the beginning of my arrows to the end of my arrows. This is my resultant vector. Okay? So that's the idea of subtracting vectors. It is flipping my second vector that I'm subtracting. Instead of subtracting it, I'm going to add that vector in the opposite direction and add the vectors normally. Okay? So you might be thinking, well, when are we ever going to use a vector subtraction in an example? Recently, you've learned that acceleration is final velocity minus initial velocity. In your data booklet, it probably looks like this without the little arrows at the top of the letters. V minus U over T. So now, most of the time, or in most of the simple cases, or the regular cases we'll be dealing with, is in one dimension. But you're required to analyze motion in a two-dimensional plane, which means your final velocity and your initial velocity may not be pointing in a straight line. Okay? So this is one-dimensional, 1D. 2D is a 2D plane. So a 2D plane means that you could have north, south, east, west. Okay? So that means you may have vectors that are diagonal to each other and you need to know how to add them and subtract them. If it's 1D, it's very easy. You subtract the numbers normally. But if it's a 2D plane, you cannot take the two numbers and add or subtract in a 2D plane. So what does that look like? Example number 5, and that should read example number 1. That's my big mistake. Michu was running east. Let's draw this. So Michu was running east at 2 meters per second, then changed her direction in 1 second. So in 1 second, she had to change her velocity. Okay? And then you might be wondering, well, if she changed her velocity, does that mean she's accelerating? Well, if we take a look, in the beginning, she goes east at 2 meters per second. Later, she goes 2 meters per second south. So afterwards, she goes south for 2 meters per second. Well, you might argue that she did not accelerate at all because her speed was the same. And you might be then wondering, why am I asking you for the acceleration if her speed didn't change? However, you have to be very careful because acceleration by definition is the change in velocity. Her initial velocity, even though the magnitude is the same, the direction is not. Therefore, her velocity is not the same. This is her initial velocity that is different in direction to her final velocity. If the velocities are different, it means she still has accelerated. Okay? So how do you find acceleration if the numbers are the same? There's no way to subtract 2 and 2. Well, the answer is you don't. That's not how you do it. Because why? This is a 2D plane. If it's a 2D plane, you have to deal with vectors using components and drawing them graphically on a page. Okay? So using vector addition, adding vectors tip to tail. Now we've now gone over the fact that yes, there is acceleration. What we need to do is we need to use some sort of vector addition or vector subtraction to figure out her acceleration. In this case, this is vector subtraction. You take the final minus the initial. So let's draw this out a little bit more carefully. We have down, this is final at 2 meters per second. And I've already drawn the direction of the arrow, so I'm not going to worry about writing down the directions. This I subtract the initial velocity, which is this guy, to also 2 meters per second, but this time this is going east. Now, according to what I've shown you before with vector subtraction, all you need to do is you take the vector that you're subtracting and add the flipped vector. The final velocity stays the same because we're not subtracting that one, but we are going to, instead of subtract, we are going to add our second vector, but flipped in the other direction. So if I want to show this step by step, it would look like this. Minus this vector, u equals 2 meters per second, and which means I am looking at this guy plus my other vector, but now it is the flipped vector. It is flipped in the other direction because it's the negative of that one. So I have to add the initial velocity in the opposite direction. So then let's draw this graphically, adding vectors tip to tail. So let's draw the final velocity. And since in addition, order doesn't matter when you're adding up vectors, it actually doesn't matter which one you add to which one first. But anyhow, let's just do final velocity plus initial velocity. So adding vectors tip to tail, whoopsies, that's a u. And now our resultant vector, the resultant vector is the same as saying final velocity minus initial velocity, which is essentially our delta v, or change in velocity. So that resultant vector gives our change in velocity. So writing all these values down, and then using, of course, Pythagoras to find out the missing side, we get that RT is 2 square root of 2 Putting that one into our calculator. This gives us 2.8. 2.8 dot 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 meters per seconds equals our delta V, okay? But she is accelerating, her acceleration happened in the 1 second. So t is 1 second, which means if we have delta V, which is this guy, to find acceleration, this is delta V over the time, or 2.8 dot 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 meters per second over 1 second, which is essentially 2.8 meters per second squared. Okay, so that is her acceleration. Notice it is not 2 minus 2 or 2 minus 2 divided by 1. That doesn't make sense. You can't do that when you have a vectors in a 2D plane. Okay, so 2.8 meters per second, that is missing something. We are not done. We need directions. We need this angle, okay? So let's figure out this angle. To figure this angle, I'm going to use my tan theta equals my opposite, which is 2 meters per second over 2 meters per second squared, the other one. And of course, if you were super savvy, you probably would have argued that this is one of your special triangles, therefore angle, the theta is 45 degrees. But if not, you go ahead and solve for your theta. This is inverse tan of 2 divided by 2, which is actually 1. This is equal to 45 degrees. So this guy is this acceleration 2.8 at 45 degrees. This is going west of south. And you are right. It doesn't actually matter which order you say, because 90 minus 45, the other angle is also 45 degrees. So, or you could have said 45 degrees south of west, which also works in this case, okay? So this is overall an application of vector subtraction. It is essentially vector addition with a twist, where you will use it, and especially when you're subtracting vectors, when you are finding the difference between two or the change between two vectors. You will see it in us finding acceleration in a 2D plane. You will also find this later when we talk about relative motion, when we look at how relative motion can also occur in a 2D plane. Later in a few units, you might even see this one in momentum as well. But vector addition will not disappear. It is a skill that you need to know. Hopefully you got something out of this. If you have questions, please let me know. Otherwise, thank you for watching my video and tune in next time on the Lead channel. Signing out.